over to Adjust. Hi, this is Mr. Roberts. I'm here to go through the Chapter 5 test, your last test. Want to give some of you just a reference point, something to look back at and possibly figure out what you did wrong, what you could do better moving forward in the future. First question is kind of strange. It's asking you to graph a function by completing a table of values. Nothing here is suggesting what values of x you should look at, so it is kind of nice that I suggest that you consider the following items before generating your table. That is, first of all, what is the axis of symmetry? What's the vertex and what's the y-intercept? So if I want to know the axis of symmetry, memorization here, the opposite of b over 2a is an effective expression for finding the x value that generates the axis of symmetry. This parabola is written in standard form. I've got ax squared plus bx plus c, so I know that b is equal to 4, and I also know that a is equal to 1/2. Here's the value of a. So I'm looking at the opposite of 4, or -4, over 2 times 1/2. 2 times 1/2, of course, is just 1. I think that confused some of you. Some of you saw that as, for some reason, 4, and you came up with -1 as your axis of symmetry. I have -4 over 1, right, which is equal to -4. So the line x equals -4 is my axis of symmetry. I'm right here, 1, 2, 3, and 4, this line. So this line is important because it really kind of helps me see, where I should be looking for values of this function. Another good thing to look at is, where's the vertex at? Of course, we find the vertex by feeding in this value x back into the function, and it'll tell me the corresponding y. I already know that the vertex is occurring when x is -4. The vertex is going to be on this axis of symmetry. When I plug that value in, f of -4 equals 1/2 times the -4 squared plus 4 times -4, and then plus 6. So we're looking here at 1/2 of 16, right? Plus, actually minus, right, plus -16, and then plus a 6. So we are looking at 8 minus 16 plus a 6. 8 minus 16 plus 6, that equals -2. So the value right here, -4 for x and y is -2. That's the axis of symmetry. So somewhere along in here, I want to include that value somewhere in the center of my table. So I'm going to go and just write it right here. When x is -2, I'm sorry, wrong. When x is -4, y is equal to -2. Great value to have in this table. Another thing that we're going to look, well, let's see, let me write that down. The vertex, -4, -2. Another value that's very useful to look at is the y-intercept, because it's so easy to get, right? When x equals 0, and let me see, that would be, I guess this way, I'll do -4, -3, -2, -1. I might have to skip something in there. I'm going to put it right here. When x equals 0, just looking at the function, when x is 0, y has to be 6. So that's another very quick, easy value to get. 0, 1, 2, 3, 4, 5, and 6. And there's also a point, I don't think I'll put it on my table, but it's reflected across here, right? It's exactly 4 units away from the axis of symmetry. And I can just go over 1, 2, 3, 4. That's another great point that I know has to be on this graph, just because of the property of the fact that parabolas are symmetric across their axis of symmetry. It's clear that roots are going to happen somewhere in between the vertex value and the values that I plotted because of the y-intercept. So I'm just going to go ahead and move here -5. -6 this way, and I'm going to go -3 and -2 this direction. And I'm just going to plug those values in and see where they're at. And actually, you know what? I'm going to bring my graphing calculator in. Go ahead. I've got this function typed in here, 1/2 x squared plus 4x plus 6. And I'm just going to go ahead and generate a table of values based on that function. Table. And, you know, so I don't have to go through and do a lot of calculations here. I can see at -6, I have a value of 0. And I can see at -5, I have a value of what is it, -1.5. And at 3, it looks like we're at -1.5 again. Oops, 1 and then 0.5. And then at -2, we're at 0 again also. So if I plot those points, clearly I see my roots, right? I've got roots occurring at -2 right here. And I've got another root occurring at -6, so that's -4. And you can see it's symmetrical there. Also at -3, I'm at -1.5 here, and at -5, I'm at -1.5. So I got a pretty good look at what this function is looking like. At this point, I'm just going to go ahead and sketch the curve, and sketch this way also. Now, I'm not trying to go be crazy or anything, but you know, notice this is a decent sketch, right? This is a reasonable sketch of what this function looks like. Certainly, I could, you know, grab my graphing calculator and ask it to graph it. Doesn't help that I've got a stats plot turned on because I was just doing a video for another class. Let me turn that off. It's good to review how to turn stat plots off. And then I'm also going to go zoom. I'll do zoom standard. And there it is.